So today we are going to start the last topic of relative motion, that is called the velocity of approach. So it is indeed a relative motion only, but in a different context. So it could be velocity of approach, it could be velocity of separation as well. So the meaning is that if we have two particles, 1 and 2, and one is following some random path, and 2 is following its own random path. And if you look carefully, you can realize something. What you can realize that the gap between the particle is as time will progress. Let's say one comes to somewhere here, 1 dash, and 2 comes to somewhere here, 2 dash, because they are moving with different speed. You can see this is the new separation. Okay. All right, this is the new separation. Then again, after some more time, 1 comes to, let's say, 1 double dash, and 2 comes to some, say, 2 double dash, and then you can see there is again a new separation. Now, as they are progressing in their motion, in their respective paths, what you see, the gap between them is decreasing or increasing?
So decreasing.
Decreasing. So the rate at which the separation is diminishing is called velocity of approach. So velocity of approach has nothing to do with the relative velocity. It is the rate at which the separation between two moving particles diminishes. So at what rate it is getting reduced? Okay. So that is called the velocity of approach. It is clear? So the definition is simple. You can just define it. It is the rate at which the separation between two moving particles diminishes or grows. So when it is diminishing, we call approach. When it is growing, we call separation. Okay. Now the question is how to find it. So because you are moving in a random path, so you have your own velocity, and we know that the velocity will be always tangential to the path. So let's call V1 at some instant, I'm saying, not in general. So at some instant, let's say the velocity is V1. And at the same instant, the other particle 2 is having velocity V2. Let's say this angle it makes is alpha. It looks almost 90, but nevertheless. Let's say it makes the angle beta. Okay. So I can draw it separately in a more better way. So let's say the first particle is having velocity in this direction. I'm going to show it inclined. What is important is the line joining the particle. So the green line is representing the line joining the particle. This is your V1, this is your V2. If I call this angle as alpha, if I call this angle as beta, what is the velocity component? So if I make 1 as moving and 2 as fixed, so 1 is approaching 2 at what speed? Can you guess? What is the rate at which it is trying to approach?
V1 cos alpha.
Excellent. And what is the rate at which 2 is approaching 1?
V2 cos beta.
So what is the velocity of approach of these two particles? So what is the velocity of approach? I'm also approaching, you're also approaching. So we are trying to diminish the gap as fast as possible, right?
Yes.
So in this particular diagram, what is the velocity with which they are approaching?
So V1 cos alpha plus V2 cos beta.
Excellent. Are you guys getting it? Prashansa, Rugved, tell me.
Yes, sir.
Are getting this? What is happening in the approach? So V1 can be resolved into two components. Let's call one as V1 cos alpha. This is V2 cos beta. Always resolve the velocity along the line joining the particles at any given instant. And also draw a perpendicular velocity. V2 sine beta. And this will be V2, V1. So what is really important to understand that the perpendicular component cannot contribute in approach or separation, isn't it? Do you realize this? Perpendicular component cannot contribute in what?
In approach.
In approach or separation. It is the parallel component with the line joining. So if you at any instant, if you simply join the particles and if you try to look at the component of velocity along that line, that will give you the idea of whether it will approach or separate or whatever. Now, what is really interesting here? What is the role of perpendicular component? Can you guess the role of perpendicular component? What it is trying to do or achieve? If you have seen this diagram on the left, you can see the line joining the particle is tilting or turning, isn't it?
Yes.
Do you realize this? So it is shrinking, but it is also rotating. Can you guess this part of what I'm saying? So as the particle is independently moving, see, they are not bound to each other. They're just moving the way they want to move. Their motion is completely independent motion. Everything else is interpretation. So what we are saying that they are moving, and in fact, they are not trying to approach also in this case. The question is not only separation, even the line joining is also tilting or rotating. Do you all realize this part?
Yes, sir.
So you can see the line 1, 2 has now slightly clockwise turned to 1 dash 2 dash. And that line is further turned into 1 double dash into 2 double dash. So there is a constant change of this is called orientation. So this constant change of orientation of the line joining the particle, it gives a sense of rotation. So this is called the rotation. So to understand the rotation part, that how much it will turn, I'll just come to this. This is very easy. So first of all, in this case, what is the velocity of approach? What is V app? So it is what is the V approach? It is the relative velocity along the line joining the particles. So the definition is simple. It is of course it is a relative velocity, but it is the relative velocity in terms of those components which is along the line joining the particles. So you can say it is the relative velocity along the line joining the, and you can see you may try to move with constant speed, but as you keep on changing, the separation will be there. Alpha will change, beta will change as you progress. Alpha will not be same, beta will not be same. So things are keep on changing. So these particles may have the constant speed. So it means the speed will not change. It will continue to be the same. And in spite of this fact that the speed is same, every particle, their approach velocity will keep on changing. We need not to mention the velocity of separation because a negative approach is separation, right? So the way of writing remains same. Like we are not supposed to write separation. We only write approach. If approach is positive, it means it's really coming closer. If it is negative, it means it is getting separated. So it's a mathematically it is taken care of. So it is commonly called velocity of approach. You could say separation, but that is not required. Okay. Okay. It is clear.
Yes, sir.
So now we can say something. So for any given situation, let's say if I do this, okay, any random, we will first try to write, learn to write the approach. So imagine this is the line, and the two particles are at the end of this line in the very beginning. Particle one is there, two is here. Let's say one is trying to move this way, two is trying to move this way. So of course they're trying to come closer. So this is approach for sure. The path is not known to us, so we'll just assume only one instant and we can resolve the velocity. So how we are resolving? Perpendicular to the line joining the particles and along it. So the along will be value v2 cos beta. Okay. And now you have realized the part that the V approach is going to be how much? V1 cos alpha plus V2 cos beta, isn't it? So I think this part is clear to all of you. Now, I was talking about what is the role of this perpendicular component. So tell me, if V1 sin alpha is bigger than V2 sin alpha, the line will turn clockwise or anti-clockwise?
So clockwise.
And if and you can also realize that what is the contribution of approach velocity in turning the line? Is there any contribution of this the parallel component to turn the line?
No, sir.
No, the answer is no. So if I make something like a elementary movement, so as you're saying, if V1 sin alpha is bigger than V2 sin beta, it will turn clockwise, isn't it? So let V1 sin alpha is more than V2 sin beta. So what will happen while going forward in time dt, it will go this way. But this will go less than this, right? These are elementary values, very small value, because we are talking about the dt time. And this is the new line. I was really interested in knowing how much it has turned in the initial direction. And it's not very difficult. This is a rotation, right? Can we call this as d theta? Tell me, guys. Can we call this as d
Yes,
theta? In time dt, how much will travel? The upper end will travel how much? In time dt. The displacement will be how much? Can we call v1 sin alpha dt? Is speed into time is called displacement?
yes,
Everyone tell me, yeah, come on. I want to listen from all of you. Rugved, Prashant, Shreya, tell me. So 1 to 1 dash we can write as v1 sin alpha dt, yes or no?
Yes.
Yes.
And the bottom will be how much then? Rugved, tell me.
V2 sine beta dt.
Why you're doubtful? The speed into time is called displacement. What's the problem? Be confident.
Yes.
So now you can see that the 2 has gone to this. So how much extra one has traveled? Because that really matters. Extra. So rotation is because of this extra moment, right? If there is no extra, will it rotate at all? If both components are
sir.
same, if both components are same, will it ever turn? The answer is no. So for rotation, it is necessary that one should move faster than the other. And this extra is how much? You can easily see this extra is v2 sin alpha dt minus v1 sin beta. Sorry, v2 sin beta. What I wrote. Okay, I have taken one more. So this extra is how much? v1 sin alpha dt minus v2 sin beta dt. Tell me, guys, yes or no?
Yes,
Yes.
Everyone is clear with this?
Yes,
Let's
sir.
call this as dl, the arc length, because it's a very small value. So we can treat this as arc length. And Shreya, you either learn to speak on the mic or don't say at all. So you can always say on the mic, you can open the mic, say it. You're not supposed to type it in the chat box. If a mic is not working, change the phone, do something, but this is not how it goes. So V1 sin alpha dt minus V2 sin beta dt equals to dl. Now you can always treat this extra as the arc length. You can think the separation as the radius. And if you know from the mathematical tools that this is like an arc length. So although it's a flat surface, but it's a very small, so we can treat as an arc length. And this is the dl. This is the length becomes the radius. This is called d theta, and we have a relationship between the arc length, radius, and the angle, right? So that is the definition of angle. What is the d theta define is? The angle is always a question. The arc length upon radius, isn't it?
yes, sir.
So how many of you realize this formula? That d theta is the dl by dl by l. Everyone?
Yes, sir.
Yes.
So do you all remember this radius, angle, and the definition of radian? Correct?
Yes.
So now d theta turns out to be dl by l. And here dl we know is v1 sin alpha dt minus v2 sin beta dt whole divided by l, which is very a nice expression. We call it, listen carefully, v perpendicular relative into dt. Do you realize this? Why I'm writing like this? It is the relative velocity of perpendicular component, isn't it? Just Okay, sorry guys. So this we can attach this upon it. Now this is the nice way of writing. So this will take you to the idea that what is the rate at which the line will turn. So the answer is d theta by dt is how much? So the answer is v perpendicular relative upon separation. Later on in the chapter of circular motion, you will come to know this is called something called angular velocity. So right now you don't know, but this is called angular velocity of particle one with respect to or vice versa. You can always say that it is the angular velocity, the turning velocity, okay, of the one particle with respect to the second particle. Understood? So this term is
Yes,
having a great importance. Okay. So this term will have a great importance, and I will complete it. So d theta by dt, let's call this. You can also use the symbol omega to represent this d theta by dt. So writing d theta by dt is not convenient. So in physics, we do have a very specified symbol for the same. This is called omega symbol. It's a Greek symbol. This is also omega, but it's called capital omega. This is the small omega. So this is, you can say omicron. So it's a big omega. Just like the English alphabet, we have the lowercase and uppercase. The Greek alphabets do have the lowercase and uppercase. And this is the lowercase, this is the uppercase omega. This omega you must have seen in the Ohm's law, right? As a notation for
yes,
the resistance. Here, the small omega we use as a notation for the rotational effect of the line joining the particles. And this formula, the way I derived the formula, is the base of learning the rotation. Okay. So in every other chapter, we do have a dedicated chapter of rotational dynamics. But whenever it comes to rotation, you need not to be like some genius. Just think this way, the way I'm saying. Think of the line joining the 2 points, 2 particles. Take the velocity perpendicular to the line. Take their relative velocity, and then divided by the separation. So if you think this way, this will always work. This will always work. This is very, very, very important for you. If you can just keep this formula in mind, it will make your life as easy as possible. So you can imagine that how powerful the formula is. Right now you may not be imagining, but I think Rugved can tell because Rugved has crossed these chapters, right? You have done with the circle motion in your coaching, right? Rugved.
Yes, sir.
So you know this basic. This is the how the rotation is done.
Yes.
So this is how we study rotation. Okay, rotation study is very simple. Whenever you talk about rotation in any chapter, just keep this in mind. If you just understand this small concept which I have explained here, you can crack any tougher question of rotation just like this, because this is the base. How rotation happens? It is happening because of the one is moving faster than the other end. If they're not moving at different speed, rotation will never happen, isn't it? So if V1 sin alpha is same as V2 sin beta, do you think that it will ever turn? The line will turn? Tell me. Line
No,
will turn, yes or no? The answer is no. Anyway, so keep 2 things in mind. That first, the d theta by dt is V perpendicular relative upon separation. I'm just writing separation. Okay. Now the question is how to write the velocity of approach. The L is the separation. L is the separation. Try to understand this mathematically. Approach means at what rate the separation will diminish. Getting a point. So separation will diminish. It means the DL will be negative because as the time will progress, you will get a smaller L than the previous one, and so the change will be negative, right? So we'll put a minus sign to make it positive number. So DL by DT is called V approach. So these two are the most crucial ideas or concept in physics. Tell me guys if you have not realized this part. This is the end of the world. The approach is written mathematically. How we write the approach mathematically? Minus DL by DT. Why minus the minus value? Because the DL itself is negative. So we are writing value. V approach. So DL is negative, so we put minus sign to make it positive. So because as you move forward, the L will shrink actually. So in this case, if I go back here, the V1 cos alpha, so it is L. After some time dt, the length will shrink to what value? What will be the new length? I can show it again. I hope you, if you have understood, then let me know. If not, then I'll do it something more. Is this clear? The approach part? I do want to explain more. Just tell me, guys. Tell me, Prashansa, Rugved, Siddhant.
Yes, sir.
Are you guys getting this formula? Like why I'm writing the way I'm writing?
Yes, sir.
Is it making
Yes.
sense to you? Rugved,
Yes.
are you sure?
Yes.
Do you realize this or do you understand this?
Yes.
What? What is?
The formula
What is formula?
minus dl by dt.
No, it's not. There is no formula in physics. In physics, we have only concept. From concept, we create formula. Okay. So seems to be okay. You guys have not realized part. See, I'm not creating a formula out of like blue. There is a logic which we followed, which gave the formula. And of course, everything should be written in certain mathematical way. So this is the mathematical way of writing. If something is shrinking, if it is L, and if we call this as L plus DL, if this is T equals to T, and if this is T equals to T plus DT, so definitely this has traveled down. How much was this? V1 cos alpha. So this is V1 cos alpha. So how much will this will travel in time dt?
V1 cos alpha dt.
Excellent. Cos alpha dt. And this will travel how much? V2 cos beta dt, isn't it?
Yes, sir.
So can I say, see, this is common sense that so V1 cos alpha dt plus L plus DL plus V2 cos beta dt equals to L. Can we write like this? Yes or no?
Yes, sir.
That's common, no? By equating the length. We are simply equating the length. So do you all realize this? Yes or no?
Yes, sir.
So now you can see this will cancel out. So how much will get DL or minus DL, you can see. So you can see that DL will be, or let's say minus DL, I can take DL that side. So minus DL will be how much? V1 cos alpha plus V2 cos beta into dt. And now DL by dt is how much? This is exactly the velocity of approach, isn't it? Is this clear? Hello,
Yes,
hello,
sir.
hello. So that's why I defined the V approach as the decrease in length upon time. At what rate the separation is decreasing or diminishing? In physics, we can arrive at a relation mathematically without forcing ourselves to mug up a formula. So you have to develop this intuition that how we create formula, how we write equations. See, if you have observed carefully, I have taken two instant. One is t, another is the t plus dt. This is called the differential thinking process. Okay. So you always, try to, write the event at the two instant, one at t, another at exactly the next moment of t. And in these two narrow, spatially, you can say event or narrow interval event, we try to create a elementary variable. So the way of creating the elementary variable is the way to solve numerics. Okay, so you have to always think of developing these elementary variables and creating the equation, and then you can solve it further. Because if things
Sir,
are all, yeah,
your DL is always positive, no?
no, in this case it is negative because it is diminishing. If it is growing, it will be positive.
So because here, when the line shrinks down, sir, why have you written L plus DL? It should be
That's
L
very good
minus
question.
DL.
Okay, that's very good question. So in mathematics, we have this is called the calculus way of writing. So what we do is, if at any event, if you write event at some instant t, and if you call the value of that variable as x, the moment you increase the event, if you say t plus dt, the next moment, the value must be written x plus dx. It is up to dx to be positive or negative. So the way of writing is always in a positive way. Plus doesn't mean increasing, right? Because
Okay,
you can add something negative, is totally okay, isn't it? So here
yes.
DL is not positive. DL is negative in the sense. Understood? So can I write like say 5 and 5 plus minus 0.0002?
Yes, sir.
What's wrong with this? Nothing wrong. So that if I call this variable as DL, then my DL is going to be negative, isn't it? And that is
Yes, sir.
why to make it positive, I'm putting minus sign. Understood? Why minus sign has come
Yes.
into picture?
Hmm.
So mathematics always goes this way. It's a calculus way of writing. So if we have two variables x and y, when x is x, y is y. So the moment you say x is x plus dx, if you have elementary change in x, this is called elementary change in x. The y will also change elementary by dy. So we always make a plus notation. It could be negative in value, it could be positive in value. We have no control over the dx part or dy part. Understood? So change could be anything. But the way of writing remains the same. And you have to accordingly manipulate the plus minus to get the right answer. So I hope this is clear.
Yes, sir.
Okay. So approach is clear to everyone. Separation is clear to everyone. Tell me.
Yes, sir.
Yes, sir.
We'll do some practice. So imagine if I have two particles. Sorry. This guy is going this way with speed u, and another particle is going this way with a v speed v, and this angle is theta. The separation at that instant is L. I want to know what is the v approach here, and I want to know what is the d theta by dt. Can you tell me both the answers? You can think of two particles, 2 and 1. So try to solve this question. Find these two terms. Everyone, do it fast.
Sir, is it v minus u cos theta by L?
Yeah, once again, the approach is how much?
V minus u cos theta by L.
This is the v approach, no? By
Acha,
L.
for d theta by dt.
For d theta dt is how much?
V minus u cos theta by L.
No, that's totally wrong. This is correct. This is v approach. That's it. See the rule number 1. To solve a question of approach or separation or rotation, you first need to resolve velocity along the line and perpendicular to the line. Have you done that? Have you resolved the velocities along the line joining the particles and normal to it or perpendicular to it? Tell me, guys.
Yes, sir.
Yes, sir.
And if you have done that, can you see at what rate they are coming closer? So V is trying to approach, but 2 is trying to go away. So what is the net approach? V minus U cos theta. Do you all realize this?
Yes, sir.
And in this case, V cannot have any component normal to the line joining, isn't it? Only U can have. So what is the component of U normal to the line joining 1 and 2? Tell me. So this will be U cos theta. So what is this component? Can we say U sin theta?
Yes, sir.
Is it hard to understand? No. So DCWT is the relative velocity of the perpendicular component. And you can see the first particle do not have any such component. So this itself becomes the turning value, isn't it? So the V perpendicular relative upon L. What is V perpendicular relative value? Tell me, guys. It is only U sin theta. Do you realize this? Yes or no?
So why didn't we take V sin theta?
Pardon?
Why didn't we take V sin theta?
How you can take V sin theta? Where is the component? Do you know how to find component? How to find V sin theta? Tell me. A vector is this way. How are you going to get this answer? So have you lost totally about the resolution of vector? No idea. Blank.
No, sir, I thought we'll take the horizontal.
How will take the horizontal? There is no theta. You can see the vector direction. The V itself is given you along the line. How it can have the component normal to the line? Is it possible?
No, sir.
Then tell me. I think you are still not getting it, yeah? Siddhant,
No,
you
sir,
realize
got
this?
it.
Yes, sir. I got it.
Rugved?
Yes.
Yes. So much doubt in this word yes.
No, sir, I got it.
You got it. So see, try to understand what I'm saying. I mean, there are some minute points. If you are missing those points, you will not get the whole idea. Understood? So there are some really minute points. You have to be like very, very crucial. Concerned and alert in listening to those catchy words, like how we derive something. Okay. And this is perhaps the basis of your circular motion also and rotational dynamics also. If you understand the motion of two particles and how the rotation is brought up by the difference of velocity, you can always get the answer. Okay, let's do this thing. Maybe I can do it here. And just use the space more judiciously. So this is a new question. So one particle is going this way. V1, let's call V. Theta. I'll keep it simple enough. At any given instant, the separation result. Tell me what is the V approach? And tell me what is the D theta?
So we approach 2V
That's
cos.
very confusing. This theta has nothing to do with this theta. So let's keep it alpha.
So 2V cos alpha.
So V approach is how much?
2V cos alpha.
I think this is fair enough for everyone, right? What is the D theta ability?
Sir, 2v sin alpha by L.
Very good. So do you guys realize this? Rugved and Prashant, tell me.
Sir, 2b sin alpha.
Yeah, Raghuvan, what you said?
How did we get 2b sin alpha?
Oh my God. You're not able to see anything, right? I mean, it's totally blank for you, isn't it? You're not able to see the motion, no components. Do you see the motion component, everything else? Do you see the resolution of vector? Can you resolve the vectors?
Yes.
So have you resolved the vectors in normal to the, I mean, along the line and normal to the line?
Yes.
What is their relative value? What is the relative velocity of perpendicular value?
Perpendicular to
The line joining.
the line joining.
See, if your concepts are not clear, you first make it clear that, I mean, sir, I don't understand what you're saying. I mean, this is how my brain is thinking. I'm thinking this thing, we are saying something else. I mean, you have to explain yourself. Only then anyone can help you. If you think that, okay, I will come to know what is going on in your mind, it's impossible. You have to think about the concept. If you're not learning something, it means your brain is not mentally prepared to, think logically. You want to learn something in a way, it's like a literature. Rather, you're learning something highly analytical. So you have to develop the brain, which is not a literally brain. It's like a purely analytical brain. If you find that listening is nicer than writing, you're into the literally brain. So have you resolved the velocity?
Yes, sir. Got it.
Got it?
Yes.
So if you follow the definition, you get the answer every time. The thing is, I'm giving you definition. Your brain is not trying to keep it. There is a sheer rejection of the ideas. It is like there's a huge resistance for your brain to learn something new. And that's how the learning becomes difficult for any child. Most of the learning is psychological. If your brain is receptive for new ideas, new thinking, new way of learning, you become a very bright and good student. If it is not, you struggle. The idea is you have to be receptive first of all. And for that, you need to have the genuine interest from within to learn something. See, you want to understand something. See, those who are scientists or Nobel laureate, are they really genius? The thing is, are they superhuman? And for your understanding, they were very average in the high school. Because the education system of any school is really bad. It will never encourage for the innovation or some parallel thinking, out of box thinking, because that disturb their equilibrium. So when you're learning with me, like you see, we are not a school. So we believe something different. We believe in the open box thinking, just out of box thinking, some lateral approach. And you are free to do everything here in my lecture. But rather you're still waiting for that orthodox method of learning that sir will give me formula, I will mug up the formula, sir will give me 10 questions of the same formula, I will write it down 10 times and I'll become the genius. And you'll get the marks. Now that was the approach of class 10th. And that's how you really did well in the class 10th. That your parents are really proud of. But after that, what? Have you developed any learning paradigm, any learning intuition? Have you changed the way things should be learned? Have you become innovative after that? Creative? Or are you really curious enough to understand something, why it is happening? I mean, it should bother you why it is happening. It should bother you why it is written the way it is written. If it is not bothering, it means you're not into preparation. You're not into this innovation of learning. If you're not getting something, it means it should bother you. Why I'm not getting this? I mean, what is really difficult here? Unless this curiosity will not distract any student, they will never learn. That's my hardcore experience. I was the very late bloomer. So you can say I was the worst student in my class. People used to laugh. Because they were marking up the thing. And since childhood only, I was trying to understand. And because no one was able to explain, so I was getting stuck. So now my pain, no one understood my pain. What is my pain of learning? I was looking for the right explanation. I didn't have enough money to buy good books. So when I grew up, when I was in class 10th, I started buying books. And then I read all the possible book in the given lecture. So let's say if I'm class 10th, so let's say I was in some board. I bought books from every possible board. CBSE, ICSE, state board, something else also, some private publisher also. And the same concept I learned from all the books and eventually found my redemption. So that day I realized that, okay, it is the problem. It was not with me. It was with the teacher who was explaining. I mean, they were trying to put as a formula, you mug up and you do this, practice this question by writing, mugging up the formula. And from that day onwards, from class 10th onwards, I can see that no one was ahead of me. Every topper of my school, they were actually extreme mediocres, rather below average. They didn't have any innovation of learning. They were just mugging up things and that's it. And they were good at it. That's why they were getting good marks. They had very good handwriting also. So that was they were getting marks with that handwriting also. But that is not learning. The JEE preparation is something really interesting. It provokes the mental, all the neurons. It fires up every synapses. You become a thinking robot, a thinking person. You who thinks day in, day out about every concept, about every theory. If it is happening with you, you're into the world of preparation. So tell me exactly, is it happening with you? Are you constantly thinking about the subject day in, day out? Be honest, everyone, tell me. Does it happen with you that you think day in, day out about the topics taught in the class? You keep on thinking about the problem. You get worried if it is not getting solved by you. You try to look for the answer, for the theory, why it is not happening. It is bothering you, literally bothering you. Tell me, how many of you are going through this phase? Anyone? Rugved, Prashansa, Siddhant, tell me. Prashansa, are you going through this phase?
Yes, sir.
Rugved?
Yes, some days.
Some days. So see, your answer is with you only. You know what is happening, right? And I need not to explain everything. You are smart enough to understand that what I just said. So it is never late. You can always transform from a mediocre to extraordinary. Okay. And no one is intelligent in this world. Tell me. Let me tell you very clearly. Not even Einstein. No one is really intelligent. And no human being has learned something which is really difficult. It is just like it happened to them. So what I have seen the common to all these scientists and Nobel laureates, they were looking for some answer and they were really bothered actually. So one, you can say, a bothering question that why things is not happening the way I'm trying. The search for that answer will make you genius. Why you're not able to solve some question? Search for it. Question your learning approach always. Don't wait for time to heal this process. No. Every human being can be extraordinary if the day they think about it and they start acting upon it. 90% of the students, they try to live in their comfort zone. They don't try to break the comfort zone, try to learn in the way. They don't bring any changes to their life or their way of learning. They remain there only. So what they do, eventually they will keep on changing the teachers. Okay, this is not good. I think maybe next, maybe next, maybe next. They never change themselves. They change the surrounding to avoid, okay, what is happening with them. It is called escaping mentality. There's a very famous, I think, saying by Mirza Ghalib. So you all understand Hindi?
Yes.
Everyone. She doesn't understand Hindi. That's good. So the shari goes this way. Sari umr ghalib. Sari umr ghalib. हम बस यही भूल करते रहे. सारी उम्र गालिब हम बस यही भूल करते रहे. धूल चेहरे पे थी, आईना साफ करते रहे. Understood what I'm saying?
Yes.
So
Yes, sir.
धूल चेहरे पे थी, आईना साफ करते रहे. Will it ever happen that you will look good? So the real problem is not with the mirror. The problem is with, this is like a reflection. It's just an anecdote. You never, think about yourself, your problem, your like where you lack. You look for the change of surrounding. There's a big, I can say line. It's a huge context. So we, as a human being, we always try to escape rather than face. And the day you decide to face, you will change actually. You will become something really great. And there are many late bloomers. See, we all are not supposed to bond with the extreme talent. Like those people who know me before class 10th, they never realize that, okay, I'm really good with subject. Those who know me after 10th, they know I was like genius. There is a huge difference. My school friends, they think, okay, I'm like the dumbest student on this planet. They still think the same way because they never saw the change. I never explained to them what I did. It is very common. That's why I'm saying we are not supposed to bond with the brilliant mind. You bond with the curious mind. You will become brilliant. If you're brilliant and curious at the same time, you are genius. Okay, so that's very simple. And anyone can beat any genius. Just work more than what he is doing. If he's working for 2 hours, you just work for 20 hours, 10 hours. You will eventually beat because the brain will rewire itself. And your processing power, your thinking ability, everything will improve day by day. And before you realize this, you have changed, you have totally a changed person. So a small change on a day-to-day basis will make you genius eventually. Make sure that you add some change on day-to-day basis. And you think a lot about every concept, formula, theory, definition, how it is being said, why it is being said. Try to remember every definition. I'm saying this to for generation. Like it is not the first time I'm giving this lecture. Every year new students come, they always make the same mistake. I always keep on rectifying. Some understand, some don't understand. But the thing is, they all understand eventually. We may not understand today because there is a huge resistance from psychological thing is like it is difficult to break the brain way of thinking. I mean, brain has some very comfort way of thinking. They never try to shatter or break because breaking is a big discomfort. So you have to break the learning way. If it is not working for you, why don't you break it? I don't know why I want to carry it, even it is not working. Okay. So this is clear. The V approach is clear, and the D suitability is clear. I hope so.
Yes, sir.
Yes.
Very good. All right. So the next thing is, I think this is a very famous question. Okay, let's keep it again. Okay. And this is oh, this we did not. Yes, we did. Okay, just once again the repetition. This is V. This is also V. This is theta. This is. Tell me what is the V approach and what is the D suitability? I mean, at what rate the line will turn? So we have done this. Now I can do it again.
V minus V cos theta.
Very good. And what is the next part?
V sin theta by L.
V sin theta by L.
Very good. See, just because you have become a good listener, you will also start learning fast. Try to create more focus while listening to someone. Someone means anyone who can impart some knowledge to you in the world. Always listen to them very carefully. At this age, what I prefer, be a very, very extremely good listener. No need to speak a bit. It's not required. Your turn will come when you will start speaking. So make sure before you say something, you listen hell lot of things. So if you have listened to 100 books, if you have read about 100 books, then you can, you are eligible to speak something. Because if you have learned a lot and the moment you start speaking, your content should be, you should not go out of content. People don't have the content to speak for even 1 hour. You can just analyze your common conversation among your friends. What exactly you talk about? Is it something learning, something meaningful, or are you only bitching each other? Think about it, your content of conversation, and tell me if the content is meaningful, useful, learning, liberating. If it is not, still you're not able to converse. So that is the meaning of conversation. When you converse, you have some content to share. And look at the people around you. They don't have even a single, you can say 1 minute content. They have content to brag about themselves. I bought this, I bought that, I got this, I got that, my daughter went to you brought something like this. They brag about it. They don't have content to talk about something meaningful. So find some good friend with some meaningful discussion around the subject which you're trying to learn. Even it may be some good beyond the subject of JEE, but it should be some subject which can benefit either today or tomorrow. Understood? So if you really want to talk to each other, with your friends, and if you want to, spend some good time, if the discussion is about some good content where you learn something, where you teach something each other, continue that content, discussion, continue with that kind of, the meetup. But if it is not of that nature, if it is just a wasting of time, like, talking something shit only, it doesn't affect anyone's life. Doesn't change anyone's life. Stop doing all those things. It's a highly unproductive utilization of time. Understood what I'm saying? You can always analyze every action which you perform at home, outside, with your friends, anybody else. So that is how you can control your environment. Okay, this is not going the right way. Let's try to give less time to this. This action is not productive. Let's give less time to this. Don't cut out because your brain is not mature enough, but try to reduce it. And eventually you see a huge change in yourself. People will start valuing you because you will become the person with some substance. That is how you grow. Okay. Anyway. So now this is the approach is done. So now let me do this problem. So this is an equilateral triangle. It's a very famous problem. And the particle on the vertex, let's say that this is called the 3-and problem. 3-and problem. So the every particle is changing the other particle. So 1 is changing 2, 2 will change 3, 3 will change 1 back to the same. So 1 is trying to go towards 2, 2 is trying to go towards 3, 3 is trying to go towards 1. Everyone is changing each other with same speed. So for any two particles, what is the velocity of approach? Approach we write for only 2, no, we can't write for 3, of course. So what is the V approach for any two particles? So it's a symmetric element. What is the V approach?
3v/2.
Very good. So it is V plus V cos 60. Correct? So if you think of 2 and 3, then the approach is V plus V cos 60, which is V plus V/2. Now this approach is same for 2, 3, 3, 1 or 1, 2 because it's symmetric, isn't it? Understood? What is the d theta by dt for any two particles? So how the line will turn? Because after some time I will show you the line will turn. So how the line 2, 3 will turn?
Sir, √3/2a.
Very good. You mean to say V sin 60 by A? Am
Yes.
I right? Excellent. Now the rate of turning of each line will be same or different?
It's the same.
So what does it mean is that every line will shrink also because you can see the approach is positive. So each line will shrink and turn, shrink and turn, shrink and turn. How to look like? So let me draw it. It's really nice. And this is interesting. So to begin with, let me draw a bigger one. So every line after some time will shrink and will turn also. So this point will come here. This will come here. So all will turn. So this will turn. You can think this way. What you realize that after some time, you will have a new triangle. Now, can we say this new triangle is also equilateral? Can we say?
Yes.
The reason is because the shrinking is same for every side. So the new side will be less value, but it will be same for all, isn't it? Understood, guys? Tell me.
Yes.
So the next moment, a similar thing will happen. All will turn and all will shrink also. The next instant again the same. All will turn. Keep on doing. Then again. Turn, shrink, turn. Okay, nice. So it's like a reducing, it's like a triangle is rotating. If you look at the triangle, it is always rotating. But as it is rotating, it is getting shorter and shorter in length. Do you realize this? Maybe. Are you guys able to realize this path?
Yes, sir.
Yes.
So this path is having very special place in mathematics, world of mathematics, and of course, so in physics, this path that is every individual particle is tracing, it will continue forever because we are talking about the particles, which means these are dimensionless objects. So if something is having no dimension, it will keep on shrinking forever, mathematically or theoretically. So where they will meet eventually? So where these all particles will meet eventually? Tell me, guys. They all will meet together at which point?
Sir, infinity.
No. Is it infinity? What is the point of meeting?
Center.
Pardon? What you said? Tell me.
The centroid.
Centroid, exactly.
Yeah, central.
So because it is equilateral triangle, the meeting will happen at centroid. And if you look at the path traced by the particle, if you look at the path traced by the particle, every particle, this is the path traced. Do you see this path? The path traced by the particle. This path is having a special name. This is called a spiral. Is this clear?
Yes, sir.
So they will ask you a question that after what time they will meet. That's a very common question. After what time they will meet. Now, tell me one thing. As because everyone is moving with the same speed, v, and v. After some time, when they will shift to a new triangle, will their velocity of approach change or remain same? What will happen to the velocity of approach? Will it change or remain same?
It's the same.
Same, because they are still on the same equilateral triangle of a small side length will shrink, but the approach depends on the shape, right? Not the size. Because the shape is maintained, so the approach, can we say? So here V approach is constant or variable.
Constant.
Constant.
So V approach here is constant, and luckily equals to 3V by 2. By definition, we know that V approach we define as minus dl by dt, the rate at which the separation is diminishing, right? That's a simple definition. We have done this before. Yes or no?
Yes, sir.
So tell me that dl equals to minus V approach dt, and because this is constant, we can integrate both sides. And I want to know when they will meet. Meeting is what? The separation, the initial separation is how much? A. What is the initial separation of the particles? Tell me, guys. Can we say A?
Yes.
Yes, sir.
And when they will eventually meet, can we say 0?
Yes, sir.
That's how it is meeting question. So the answer turns out to be how much? If you integrate, you will get minus A equals to minus V approach into T. That's it. Minus is cancelled. So you get T equals to the initial separation upon V approach. And this is always true if V approach is constant. Don't apply for those cases in which the V approach becomes, some function. So whenever you want to know the time to meet, if you know that the V approach is going to be constant, the T will be always initial separation upon V approach. It's very simple, plain and simple. Understood? Clear? Tell me,
Yes.
guys. So what is here? V approach we got 3V by A2. So answer is after 2A by 3B, they will meet. You can apply this relation for any shape where the symmetry is maintained. So you can convert this to any polygon. So I'll just go to for n-sided n-sided regular polygon. So for n-sided regular polygon, so for n-sided regular polygon, we know that, okay, so every particle is chasing the next particle. Let's say with the same speed V. This is changing this particle with speed V. We know the angle, right? This angle is how much? Any guess? Okay, what is this angle?
2 pi by n.
This is 2 pi by n. And what is this angle?
2 pi by n.
So what is the velocity of approach, guys, here? For the particle 1 and 2, what is the V approach?
V minus V cos of 2 pi by n.
Correct? And now after what time they'll meet? And this is going to be constant because if it is uniform velocity, then V approach remains same because every line will turn by the same value. So the polygon remains the polygon, but it will be shrink in size and will rotate. Okay. So the T becomes A upon V approach. So answer is A upon V into 1 minus cos 2 pi by n. You can put a value of n, you will get the answer for triangle, square, pentagon, hexagon, and whatever. So for triangle, what is the n?
3.
So if you put n equals 3, what will get the answer? Cos 2 pi by 3. You know, cos 2 pi by 3 is how much? 2 pi by 3 is cos 120. And cos 120 is how much? Minus half. I hope you remember this. So this will become 2a by 3. So by putting the value of n, you can get the answer for any. Now comes the interesting, something really Interesting. So this is called the Tom and Jerry problem. Tom and Jerry. So Jerry is going along this direction. This is called the chasing problem. So what is chasing problem? Like when you chase someone, the person who is being chased is unaware of it. Okay. So here Jerry is being chased by Tom. But Jerry is totally unaware of this fact that it is going to be caught by the. So let's say Jerry is moving with speed u. And at that instant, when the Tom sees the Jerry, the distance of Tom is L away. And you're trying to chase. Now you need to understand what is the meaning of chasing. When you chase someone, then you always try to go towards it. Towards means you will try to approach it. Understood? So let's call this is particle 1, this is particle 2. In the very beginning, how the particle 2 will try to move? To catch the Jerry? Tell me.
As a perpendicular.
So nice. Okay. I always did something dangerous. Okay, so this guy will try to chase like this with his speed view. But after very next moment, you are no longer here. You are somewhere here. Oh, this is too much. I can say after some time, let's say you are here. And by that time you are here. So now you will have a new direction to approach, isn't it? So now how this Tom will try to chase this direction. Understood? But again, at the very next moment, what will happen? You will be here and Jerry will be here. So you will keep on changing the direction of chase, isn't it? At the very next moment, what will happen? Tell me. So you are here. And you can see this will keep on happening. You are not trying to chase this way. And eventually, if you keep on doing this, if I join a lot of line like this, and mind you that here the cat can run faster than the rat. So V is more than U. Because for chasing, it is necessary that the person who is chasing must be moving faster than you. But if you can't move faster, you will never be able to catch it. For the obvious reason. Because you can see in the same time, who is traveling more? Who is traveling more distance? One or two?
The person with velocity 2.
Pardon?
2 is
Yeah, 2 is always moving more. Because eventually you have to, you have to catch the guy by traveling more distance. The guy is moving slower than you, so you can eventually catch. And then like this. And eventually you will catch. Do you see the path traced by the Tom? The path is constantly changing, isn't it? Whereas the
Yes, sir.
path by the JEE is constant. You can see it's a straight path. So in this case, the approach is constant or variable.
Variable.
Exactly. So now you cannot apply the formula which we used before. So here, if you have realized this part that the V approach is not the same, so you cannot apply the previous formula as you did it. Okay. So therefore, we have to do the integration from scratch. For a mathematical simplicity, we can call this as X direction. Okay. When both will meet together, or in a way, when the Tom will catch the JEE, they will have same X coordinate, yes or no? The two will have same coordinate. Tell me, guys, yes or no?
Yes.
Yes, sir.
Which coordinate? X coordinate. So they will meet at only one point. No? They can't meet at 2 points. That's impossible. So the meeting will happen at one point. So they will have same X coordinate. So we can write something. Okay. So how to approach this problem is, so we do like this. I mean, this is the very standard you are seeing for the first time. You need to learn. Next time you can solve. Okay. Without worrying much. So imagine I'm taking some random instant here. So my particle is here and here. Okay. So the JEE is going this way with speed u. I don't know what about this angle. So I'll just call this angle theta with horizontal with x-axis. And Tom is going this way because Tom has to chase. So the one who chases will always point towards you. So chaser is always, aiming towards the target. So if someone is chasing you, then his instantaneous velocity will always point towards you. That is the whole idea. It is clear what I'm saying? So in any chasing problem, what is the condition? The chaser must be aiming towards the target. The chaser always aim towards the target. That is instantaneous velocity of chaser will be along the line joining the particles. I hope this is clear, the chasing condition. So tell me, what is the V approach at this random instant? So the random instant which I have drawn, what is the V approach? We can write.
V cos theta minus U cos theta.
Just Okay, sorry guys. So now what has happened is the JEE has announced the mains date suddenly. I mean, out of blue. I mean, it was not expected, but they just announced. So it's a panic situation across India. So I'm getting a lot of calls for the same actually. So V app. Now tell me, what is the V app at this instant, Siddhant? What is V app?
So v cos theta minus u cos theta.
V cos theta. V is along the line only, no? This is V.
Achha, sorry, v minus u cos theta.
It is V minus U cos theta. How many of you are able to realize this? Tell me, guys.
Yes, sir.
So can we write this as minus dl by dt equals to V minus U cos theta? So minus dl will be how much? V minus U cos theta into dt. Now tell me, theta is a variable or a constant? Theta is what? Is it constant or is it a variable?
Variable.
Definitely a variable. So can we integrate? The answer is no, we cannot integrate. So when time is 0, L is L. When time is t, it is 0. Because at the time of meeting, we can say this must be 0. So now, the answer will be simple. It is L equals to V dt integration. Let's make it tau, it's look nice. 0 to tau minus u cos theta dt integration 0 to tau. Now, there is a nice trick to integrate this because you cannot integrate cos theta dt. So this remains like this and we are stuck here. We cannot integrate. That's a reality. But if you remember carefully, they will meet at the same point, isn't it? Which means in the time of meeting, both will have equivalent x displacement, yes or no. So however the cat has traveled, the x displacement is same for both. Do you realize this? So cat has gone from here till here. Okay, so cat has gone from here to here. What is the x displacement of cat? Can you guess? What is the x displacement of cat? Isn't it same as the rat?
Yes, sir.
So we can say x displacement of cat is same as x of the rat. How to write the displacement? So what is x cat equals to x rat? X rat is easy to write. Why? Because it's a constant speed u tau. Can you write like this? Tell me. What is the x component of velocity of cat? What is the x component of the particle number 2? Tell me. What is its x component?
V cos theta.
V cos theta. So to write the x displacement, you must write the x component, which is V cos theta dt integration. And now you can see that V is constant, so we can write V outside is cos theta dt. See, I'm still not able to integrate, but I can express this integration luckily in terms of this. And therefore, now you can see from equation 1 and 2, from 1 and 2, what will happen? You are able to write L equals to V tau minus, it is I think u into cos integration is how much? U tau by V. And now it turns out to be something really nice. V square minus U square into tau by V. So time in which it will catch is this answer. So this is a very famous problem across every book. This is from Erodov actually. And the chasing problem is a very common problem you will find in every textbook, every examination of coaching institutes. And although I mean, JEE has not asked question of approach or chasing problem, but this idea also helps in solving some of the more challenging questions. So this part you can say If you are preparing for KE, PHY or Olympiad, you can expect these questions quite a lot. So it's a very common question in Olympiad, the chasing problem, and the application. See, everything which you learn will have somewhere. I mean, if you're lucky enough, you can also see the application somewhere, and then there these ideas will help that how to approach a problem in this kind of situation and so on. Okay, now there is an interesting you can say variation. I just take 5 minutes and I'll finish it. Don't go away. And that is what happens if both the parties are trying to move with the same speed. So if both are having same velocity, if this is v, this is also v, if this is 1, this is 2, will they ever catch? For catching, it is necessary that v must be more than u, right? You can see if v equals to u, what will happen? Tau becomes infinite, which simply means it will never catch. You can also see if v equals to u, what will get the tau? Infinity, isn't it?
Yes, sir.
Which means it will never catch. So what will happen in that case? In that case, eventually, when you will keep on chasing, when you will reach this line of the particle number 2, oh yeah. So you will see that if one is reaching here, 2 will be much ahead. Why much ahead? Because they are having same speed. So they will travel same distance, not the same displacement. So the length of this arc, if you stretch it, will it be here or will it be more than here? So the 2 will also travel the same length, isn't it? And if that length is same, then they cannot be at the same place. Yes or no? Do you realize what I'm saying? If 1 becomes at 1 dash, the 2 will go to 2 dash, and 2 dash must be ahead of 1 dash. Yes or no?
Yes, sir.
Because both are traveling same distance. So the length of path is same for both. So this stretch will have same length as this stretch. Do you realize this? Can we say this length is same as this length? Is it correct to say? No, it's not correct to say. So now the question is that how to solve this question? See, there's nothing more. You have to do the same stuff. Take some random instant. V, assume angle theta. Write V approach. What is your V approach now? V, 1 minus cos theta. Right, Siddhant? We have done this before.
Yes, sir.
And if this is the V approach, then we can write minus dl equals to V approach. I'm writing now fast. dt. You can integrate from L to, no, from L to 0 is not possible. So we have to assume this as the separation. And now once you are on the same line, your separation remain constant because both are having same speed. So V and V, so the D becomes constant. So we can say the final separation is D. It's not V. And this is unknown. I want to know this actually. What is the final separation between them? So the answer turns out to be L minus D equals to V into tau or T, whatever. You can always write this as a V or yeah, fine. So T minus cos theta dt. You can write like this integration. And now if I write the X relation, what is the X2 dash? And what is the X1 dash? So we can say X2 dash minus X1 dash eventually will be how much? Can we write like this? So D is how much? X2 dash minus X1 dash. Yes or no? Tell me, guys.
Yes, sir.
So X2 dash is the topmost. This is V into T. And X1 dash is again V cos theta dt. and I can replace. I can simply replace. So, okay, this entire term is again here, right? Isn't it? So both terms are same, no? Do you realize
Yes,
this?
sir.
So from these two equations, what you can say? L minus D equals to D. And therefore D becomes L by 2. It means when they have same speed, then the final separation will be half of the initial separation, no matter what. For this situation, I mean, if we start moving like this. So with this question, I can say this is the end of kinematics. So happy kinematics, you studied a lot of kinematics. Don't leave it. Okay, keep on solving kinematics on a day in, day out for the next 1 month. Always solve kinematics, at least 4 to 5 questions every day. Okay. If you are getting deprived of questions, just let me know. I'll give you more and more questions. So if someone is more interested, you can just let me know. I'll give you some Olympiad level questions, something not Olympiad, I mean from JEE to Olympiad, mix of all. Okay, so there's a huge collection of questions I have for the kinematics, only for if you're interested, and if you really want to solve every day, keep on showing me that you're solving every day. I'll give you some nice question. Okay. Revise the notes. Keep the notes always handy. Don't put in some shelf. Keep it always handy. Keep on revising every day. Make sure that you at least turn the pages to see the notes. Take the printout of the PDF. So I'm going to make the entire kinematics PDF into one single, and I'll share with you guys. You can take the printout and keep a physical copy. Okay. Don't take printout at home. It is very expensive because the black ink will be consumed hugely. I think that is the problem, isn't it? So yeah, this is how it goes. In many cases, printout is good. If you can print out, it will be helpful, but it's costly affair at the same time. So you can cut, paste, and make a small, nice PDF, because a lot of space is left in PDF. You can make it a nice one if you know how to do it, and then you can take a printout. So bye guys, take care. We are going to start a very new topic in the next lecture. That's laws of motion. All right.
Bye, sir. Thank you, sir.